Welcome back now. In the last class we discussed about what is SQL and what are the different the sub languages of SQL and what are the different the commands used in each sub languages of SQL. Now we will discuss in detail how the each command works. Okay. So as I discussed, DDL is used to create, alter and delete database objects. The database objects like table, views, schema, index and etc. So, these are the database object. Okay. So, any things that we create in the database we call them as a database object. Okay. So, as I told in the last class, so table in DBMS terminology we call them as a relation. Then how the relation look likes in the database? Okay. So, that is the relation, this is called the relation, or in general we call them as a tables. The fields of table we call them as an attribute. These are called attributes. These are called attributes. Every relation is given a name, right? A name, and that we call them as a relation name, right? So now, so product is a name of the relation, right? Relation. So each relation consists of attribute, right? Say for example, P name, price, category and the manufacturer. So it's called as a attribute of a relation. This is a attributes of a relation. So these are the each, as in general when you describe a table we call it, so we describe table as a rows and columns. So this is called row, this is a column and say this is row, right? This is row. Each row in relational database management system, that is RDBMS, we call it as a tuple. Each row, this is called tuple. Each row in a RDBMS call it as a tuple. So now these are tuples. These are tuples. So this is a brief about the relations. Means table in a RDBMS we call them as a relation. Each relations will be given name and we call it as a relation name. Each relation associated with the attributes and are in general we call as a fields. So every rows in a table we call it as a tuple. So now, as I discussed, the data definition language, that is called DDL, has some commands. Among them is create is one of the command. Then why we use the create command of DDL? The create command is used to create a new relation and it provides name of the table. So, right, if you want to create a new table in a DBMS or database, in the database what we do is we are going to use create command. When you use a create command, so you have to provide the name of the table or called the name of the relation and the attribute and the data types. You have to give them attribute, the attribute name and the name of the data type and the constraint that you want to impose on the fields or attributes. Constraints are nothing but the rules that you can impose on each attributes, or you can define a guidelines on each attributes. So this is a syntax that how to use the create table statement. Create table followed by name of the table and say column 1, I mean to say that attribute 1 and the data type, what data that you want to store in the corresponding column. So column 2 data type 2, column 3 data type, and it goes. This is how you can use create statement. So while if you want to create a table or called relation in the database, then we are going to use this syntax, create table followed by name of the table followed by the column and corresponding attribute, the data types. So this is an example. The create command is used to create a table called department. This department table are called relation in RDBMS. So now this department table consists of dname, means we are creating a fields or attribute for department is dname. The type of the data that you store in the corresponding dname field is varchar. Okay, just I will discuss what is varchar. Then d number, this is the name given to the each department will be given to a department number, and so already we know that this is normally we use it as an integer. Then say manager SSN, that is the manager who is going to manage the department. Okay, this is how. So these are called constraint, this is called data type, and this is called attribute name. Name of the field, the data type, and the constraint. So that is what the create table says. To create a new relation, as a called new table, we have to use this syntax. So once the create table command is executed, this is how it will be get created in the database. This is called the department relations will be created in the database in this manner. So department, d name, d number, and manager SSN. Next is a drop table. As I discussed, when drop table SQL command removes a relation and its definition. As I said, definition is what? The different attributes associated with the table. So when you don't want the table to be present in the database, then what we have to do is we have to delete the table from the database. Then how to delete a table from the database is that you have to use drop table command. So the example is say drop table department. So whatever the relation that you have created with the create can be deleted using drop command. So the syntax for this is drop table department. This is the name of the relation that you would like to remove from the database. Next, as I said, so the alter table, which is a DDL command, right? So DDL command says alter table used to add an attribute to an existing relation. As I said, so if you wanted to add additional fields to an existing table, then what we have to do is we have to use alter table command. The new attribute will have a null values in all the tuples of the relations. What is that null value? Null value is nothing but the value which is not present at the particular moment but can exist in the future. It can exist, the value for the corresponding field may exist in future. That's why since we are adding a column after once the table is created, so we do not pass any values when you are creating a new column or when you are adding a new column to the existing table. So in such case, so in place of value, the it is going to add or it is going to place null, right. So, null value in the all the tuples for means whatever the rows that has been already created for corresponding rows, the null values will be get replaced. Not null constraint is not allowed for such an attribute. So, assume that the you have already been created a table with a field and you have imposed a the rule are called the constraint on the existing table, and if you want to add, if you and in case if that is not present, if that when you are adding a new the field to a existing table, so what you have to do is you have to pass the values. If you do not pass the values, then what does it will do is it is going to throw an error saying that the the null value is not allowed when you want that column not to accept any null values. In such cases, what you have to do is not null constraint is not allowed for such an attribute, means when you are creating a or when you are adding a new column to an existing table, so you cannot specify not null, because when you are adding a value, when you are adding the field to an existing table, so by default the database is going to place a null value. Okay, in such cases, what you can do is you cannot create a or you cannot add a new column to an existing table by defining not null constraint. So, alter table adding a values to the tuples can be done using update command. So, means if you wanted to add any values to a latest added column, so what you can do is you can use update statement, right. You can use update statement to place or to update value for the recently created field. So, for example, alter table say employee. So, this is employee is nothing but is the name of the relation or say name of the table. So, now if you wanted to add a column to an employee table, so what you can say for example say job, you want to add a field called job. So, then what you have to do is you have to use this syntax alter table employee add, this is the name of the column that you want to add to an existing table, existing relation, and the corresponding data type, what are the data to be stored as a part of a job. Okay, this is how you can use alter table to add an column to an existing table. So, this is how after adding say department alter table, what you can do is, so now here you can say d name, d number, manager say manager start date. So, manager start date, so sorry, this is the employee. So, if you wanted to add a new column to a department, so what you can say in the previous the previous example we created a department table with this field. Now this is one more field has been added recently, that is called manager start date. So, now there are various data types that is supported by SQL for storing the data. So, these are the basic different basic data type used in the SQL. So, numeric data type, it is used to store the integer number, say we can use integer or int based on the convention supported by database. So, for storing floating point values, what we are doing is we are going to use float or real or double. So, these are the data types that we use that we are going to use to store the floating point values. So, if you wanted to store any character, so right, if any character, then we are going to use a data type called char of size, n specifies the number of characters that you wanted to store as a part of value. So, that is n is nothing but size, right. So, the character, or say again say this is in the some RDBMS that supports character as a data type and some supports char. So, then say varchar. Varchar is another data types used to store alphanumerical values. So, and say this is n specify the size, means number of characters that you would like to store. Next char, say varying of n. So, this is another data type used for storing character. Then what is the difference between the char and the varchar? So, in SQL sometimes we use char and sometimes we use varchar. Then why it is so? The character, say in case if you know that the number of the size of the column, as a size of the data is fixed, size of the data is fixed, then you can go for character. So, if you do not know what is the size, means size of the data that you wanted to store, it may vary. Sometimes you may store say 10 characters, sometimes you may store 20 characters, right. So, in that case what you can do is you go for a varchar. So, that is called varchar, stands for variable length. So, means data that you are going to store in in such fields will vary. So, bit is used to store the bit values in the form of zeros and ones. So, bit varying line, say this is a fixed size, this is a variable size. So, then say boolean, this is another data type for storing the boolean values. So, that is say true or false. So, 0 represents the false and true represents 1. If you would like to store the date type values, then we are going to use date data type. So, date data type consists of the year, month and day in this format, that is YY, MM and DD. Say this is a year, this is a month and this is a day. This is how the database store the information in the table in this format. We have additional data types, say called timestamp. This is the timestamp is another additional data type provided by SQL for storing the data in the including timestamp, right, including timestamp, like say it will be like YY, say MM, then say we have DD, next hour, next is a minute, next is a second. So, this is how you can store the data. So, when you wanted to store the data with exact time, at what time the data got updated, say for example, in such cases we can go for timestamp. But if you do not want say the timestamp, then just you can go for a date, right. If you wanted to store the data in date format, so then what you can do is you can use a data type called date. Along with the date, if you want the time interval, then you can go for timestamp. So, now, so once assume that, as I said, you can impose the rules or the conditions on each field of a relation or on each attributes. So, what we call them as constraints, right. The constraints are nothing but the rules or the conditions that you can specify on each attribute of a relation. So, basic constraint that we are using is say key and the referential integrity constraints, right? Key constraint and referential integrity constraint. These constraints restriction on attribute domain and nulls, right? It is going to restrict data that you are going to store, right? That is called restrictions on attribute domain and null values. Means in such cases you can define constraint. The constraints on individual tuple within a relation, means the basic constraints that we are going to use are key constraint, referential constraint, then say attribute domain constraint, null constraint, and the constraint that you can define on a individual tuple, right? Individual tuple. These are the different the constraints that you can specify over a relation. Specifying attribute constraint and attribute defaults. So this is how, means what you can do, different, we can specify different constraint on the attributes of each relation. So what are those, what are the different constraints that you can specify? One is that not null, right? Not null. That not null constraint do not allow null values to be inserted for the particular column. Say for example, say when when you want to have a the mandatory values, right? So the values means the particular field, if you want that field not to be null, in such cases what you can do is you can make that field not to receive the null values. In that case what you can do is you can use not null constraint. Next is a default, right? Default, if you wanted to supply some default values to the respective fields, we can use default values. Say for example male or female, or say admission date, right? So there are some default values, right? In that case if you want to supply any default values for the respective column, then we use default. Next is a check constraint. So check is another constraint that you can define over a relation, or say we can define over a attribute. Then what does the check constraint do? So it is going to check whether the value is in whatever the values that you are going to supply, whether within the range or not. Say for example the D number, right, department number that you are going to enter for the department number column. So it should be between, say, should be greater than 0 and less than 21. If you try to enter the value less than 0, and if it is less than 0 and say if it is greater than 21, so then it is going to throw an error. Means once the check constraint is defined, then the particular column will receive only the values between 0 and 21, right? So these means these are the constraints that we specify during database design. Once this constraint is defined, then it is the responsibility of the database to make sure that the respective appropriate value is stored in the relation. So this is these are different tables created with a different constraint. So look at here, this is a table called employee, is created with a table, create table with different fields, or say called attributes. Say attributes of these tables are D number, then say we have got the SSN, super SSN, then we have SSN, then we have D number, we have D number. So these are called attributes of a relation called employee. So now we have made department number as a not null, department number followed by the data type, and what is the constraint that you want to impose, and what is the default value that you are going to store for as a part of department number. So this is a constraint and this is one more default constraint, means you can specify more than one constraint for this, the fields. So now, so we can also define a primary key constraint. Then what is that primary key constraint, right? What is that primary key constraint? That I will discuss later. So next we have a foreign key constraint. This is another type of constraint that you can define over a attributes of a relation. Okay. See, this is another table, say department. Okay, this department table will be created with the following constraint, say primary key constraint, say unique constraint, then foreign key constraint, and etc. So these are the, altogether forms a database, means all these are created because the employee table, department table, then say department locations, in one or other way they are related. That is why we group them and we create in a particular database, right? Say particular database. Now what is the primary key constraint, right? This is a primary key constraint. So while specifying the primary key constraint on each table of a attribute, we must ensure that so in the the first module we have discussed the advantages of DBMS, right? What is that? There is a advantage, say it controls the redundancy, right? It controls redundancy. What do you mean by redundancy? Without duplicate values in a relation, right? Without duplicate values in the relation. Now the primary key constraint ensures that every tuple or every tuple or every rows in each relation are unique, right? Relations are unique. Specify one or more attribute that make up the primary key of a relations. So means you can make one of the field as a primary, single field as a primary key. In case if you are not able to make up the primary key using a single field, then we can go for another field to become to make a primary key. So D number, so is again say primary key to ensures that department created in the department table are unique, right? The primary key ensures that every records in a relation are unique, right? Are unique. Next is a unique constraint. This is one more constraint that you can define over a relation. So then what is the difference between this? Is also maintain the unique value. This field also, this constraint also maintains the unique value. Then what is the difference between these two? Please note that the primary key value or the primary key constraint that you define over a attribute do not receive a null value. Do not receive null value means you cannot add null values to the field that defined as a primary key. Then the what does the unique key does? The unique key also stores a unique value for the corresponding attribute, but receives single null value, only one null value. Say for example, say 1, 2, 3. Assume that this is a say SSN, right? SSN for a employee, the SSN. So we know that a employee cannot exist, any employee records cannot exist without SSN. This is called employee number, that is similar to employee number in say US, say a social security number. SSN stands for social security number, which is the number given to every individual of the US citizen. So now no citizens exist without SSN. It means that this is the mandatory. You cannot add null to the SSN. So if you wanted to create a record without null, you make such field as a primary key, right? Such field as a primary key. But whereas in say unique, the unique may receive one null value. Say for example, if you define any of the field as a unique, then what you can do is say it can receive one null value. So it will not store more than one null value. This is, it will reject. It will going to throw an error for the, in case if you try to insert a null value for the second record. It means that if you look at these two, the primary key do not receives a null value, but whereas the unique key receives only one null value. So that is how it is going to maintain a unique records in the relation, right? So that is the major difference between the primary key and unique key. Primary key identifies or stores the unique records in the each table without null values, but say the unique key, it also stores the the unique value, but allows only one null values to be stored for any one of the record. The stores unique value but allows only one null value. So you can define the unique constraint like this: the name of the field or the name of the attribute, the data type, and the constraint that you want to impose on a relation or say relation attribute. Next is a foreign key constraint. The foreign key constraint is that when you want to build a relation among the tables, when you want to build a relations among the table, then what we do is we are going to use foreign key. Suppose assume that we have a table A as a called say employee, say employee table, say as I say I'll just show. Say assume that this is a relation, this is one relation, this is another relation as another table, this is one assume that this is a table A and say this is a table B. So this table stores information about some student and this stores the information about some course. So now this table A consists of roll number as an attribute, name as an attribute, address is an attribute, and say this course contains the course ID and the roll number. So whoever gets an admission to the corresponding course, that information will be maintained in the separate table. This is the table A and say this is a table B. Though they are, it looks like an independent table, but these two tables are related by some way. What is that way? We don't know. You have to create, right? We have to create a relationship, right? A relationship between this table and this table. So such that the whatever the data that you entered in each table will get related each other. Then how do you create a relation in the database? So that is by using foreign key. Foreign key. The foreign key is a key used to create a relationship among the table where if you feel that data present in the two different tables are related. If you create a relations among the table, that relations will exist as the parent child, as parent child. Then what is that parent child relationship? Parent is a table without which a child cannot exist. It is like in parent child relationship in general, right? So that can be say the parent and child relationship can be created with a foreign key. So now what we can do is a student can get an admission to the courses which exist. The courses which exist. A student cannot exist, right? Cannot exist without course. A student cannot get an admission to the course which is not exist. Okay. So it means that the course first exists, course table first exists, then the student table, right? Then the student table. Then what we can do is, so now the course will become a parent, then student will become a child, right, child. So, means those students can get an admission to the corresponding courses. So, that is how, that is means the you can, if you wanted to create a parent and child relationship among the tables, then we are going to use foreign key. Just I will discuss later in detail. Thank you.